How are you, everybody who is watching this video? I'm very happy to have you, whether you're an international or international viewer. I would like to welcome you into these fantastic programs of online diploma training. Well, I would like to take this opportunity to introduce myself. My name is Olenjolai TAYAI. You can just simply call me Sir Olenjolai. I come from Tanzania. I'm a Tanzanian and also I live in a beautiful country. And I'd like to welcome any international viewers to visit and live in our beautiful country where God lives. So I'd like to take this opportunity, first of all, to welcome you into one of our online institutions. And this is, it's not a school actual, it's a kind, it's institutions, so institute, okay? So institute name, it is called the Online Diploma Polytechnic Institute of Tanzania. Online Diploma Polytechnic Institute of Tanzania. Let's take this opportunity to welcome you into one of our YouTube channel, which is our official YouTube channel, which is called the Online Diploma Polyinstitute of Tanzania (OLENJOLAIM). So after that, this is the name of the institute. So institute name is called the Online Diploma Polytechnic Institute of Tanzania (OLENJOLAM). So before we go into too much details of session, this is session 4 or lecture 4. So it's either session 4 or lecture 4, everything is okay. So before we go into too much details of this session, I would like to spend a few minutes just to give you the overview. One thing which I would like to share with you is actually, I would like to remind you if I have spoken to you or you have heard from my mouth, and also I would like to take this opportunity to tell you if you are first time to watch my lecture videos. The point is, you might be asking yourself for the visions of Online Diploma Polytechnic Institute of Tanzania (OLENJOLAM), because according to the book of Proverbs chapter 29 verse 18, it stated where there is no visions, people perish. Where there is no vision, people perish. So remember that I told you that this is our national flag. This is the national flag. Whenever you find this actual that it has been suspended in a particular tower, then you have to understand that this is representing Tanzania. So the vision that we have in Online Diploma Polytechnic Institute of Tanzania is actually to teach and train and incubate and also to mentor some group of students who will be ready to take to extract knowledge and wisdom from either formal or informal diploma, informal knowledge, whether from informal educations for ordinary diploma in engineering and science. So that's and combine it with the knowledge and wisdoms of the Word of God that found in the Holy Bible. So that's the point, in order to solve real life problems. So simply the vision that we have in Online Diploma Polytechnic Institute of Tanzania (OLENJOLAIM) is we are here to train and incubate ordinary basic technicians in engineering and science programs who will be ready to extract knowledge and wisdom from the informal and the formal educational contents, and combine it with the knowledge and wisdoms that we are going to teach them and train them to extract it from the Word of God readers in the Holy Bible in order to solve real life problems. So the main objective of Online Diploma Polytechnic Institute of Tanzania (OLENJOLAIM) is actually that to train our continuing students, or our continuing students of the present and future generation, and also our graduate students who are basic technicians. It means that to teach them on how they can solve real life problems by using the knowledge and wisdom that will be teaching them according to the curriculums, and even sometimes some of the courses or modules that will be designed particularly in order to get a particular knowledge. So we'll be teaching you basic mathematics, basic engineering and scientific mathematics, And I'd like to welcome you to the Departments of Basic Engineering and Scientific Mathematics, and also the courses called Conics and Differential Equation. So we are in chapter 5, which is called Differential Equations, and this is session 4, Formulations of Second Order Differential Equations, and this content is for Nta Level 60 or ordinary, this is ordinary diploma 30-year students. So just to insist you concerned about this program, we have so many departments, and the Nta Level 60, that is 30-year ordinary diploma in engineering and science courses, or even some other courses. N stands for national, T stands for technical, A stands for award. Okay, so it means that this is contents are for the 30-year students, but we'll be focusing on the NACTE syllabus and NACTE curriculums. NACTE, it means that we'll be focusing on curriculums of Tanzania, which actually that has been prepared to train basic technicians in the ordinary diploma first to 30 year. Okay, so we'd like to ask you that to be connected, because we are going to do actual fantastic things in these online institutions. And in order for you to be connected throughout the entire programs, possibly that until you graduate, or also that until that you find you're satisfied, you can have to click this button on your right hand side and subscribe. And as once you click, it will disappear, it will change color, it won't disappear, it will change color, that becomes gray, because before subscribe is red, and the color of the background is gray, and then this way also will be changed into subscribe. Okay, so again, click this layer and you see the options, then choose that I want to be notified for all notifications. Okay, so as I say that this is session 4 or lecture 4, I would like just to do the quick review. So quick review of the previous lecture, which was lecture 3. Okay, lecture 3. So lecture 3, it has been titled as Formulation of 40. So simply, first of all, we taught you introduction of what? Introductions of formulation of 40, formulations of differential equation. And then later on, we taught you about the formulations of first order ordinary differential equation, right? And then also so formulate the first order ordinary differential equations. But again, we taught you about the problem solving, or we solved some problems, or problems solving in first order differential equation. And then we left the homework for you, and we'd like to do the minor corrections on the number in the examples. It was homework 3, so I numbered as example 6, so I repeated the numbering. So instead of that, just change and write example 7. I believe you did your homework and you submitted in the comment section, and I believe that was just like to strengthen you on the concept that I taught you of how you can use the given functions of the solutions of the differential equation to formulate what is the first order ordinary differential equation. So that's all about what we have discussed, and I'd like just to take you. So remember that we said one thing that which I would like to remind you. Remember that we say that the first order or the function FCT of solution, this is solution abbreviations of solutions of what? Okay, the functions of solution, the function of solutions of what? The function of solutions of first order, we say, if you do remember, contain only one arbitrary constant. So in order to eliminate it, if you do remember, I told you that differentiate the given function only once. Differentiate the given function only once. Okay, that's what we've discussed. So ladies and gentlemen, let us go to today's that we call formulations of second order differential equation. And let me begin to give you a little introductions, and actually I want to teach to present to you on the big picture. Next, we'll go to the, means that you will be solving those second order differential questions. So in these introductions, I'm going actually to teach you two key concepts. First of all, we say that how can you discover that the given function will give you the second order, or the given function of the solution is the solutions of the second order differential question. This is the technique. So we say that let me just take this out so you can see everything that you're going to cover. Okay? And then I just I have to change the lighting, because I think there is too much lighting. Okay, so right now everything is okay, right? Okay, so you say that the function of solution, of differential equation the function of solution of differential equation of second order contains only two arbitrary constants. Okay, not more than two arbitrary constants. To say, for example, it can be A, B, it can be maybe capital A or capital B, etc., etc. So that's the key point. The function of solution of differential equations of second order differential equation. Okay, so let me do this correction. So of second order differential equation contains what? Only two arbitrary constants. That's the first key point. So we say that, for example, you see that something like this one, examples of this kind of the function. You see that y is equal to ax plus b, and also you can see that maybe y is equal to e power twice x. Then we have ax, then plus arbitrary constant b. Again, we can have, let's say, another example that can have, we say that we have e power x, and then we have cosine, or we have arbitrary constant a, can have arbitrary constant a, cosine of what? Okay, let's say cos of x plus b sine of x. Okay, sine of x. So we can have a solution like this. So you have different ways. Also, you can have a solution of second order e power negative x plus b e power 3x. So all of these are examples of functions of solutions of second order differential equation. So another key point, in order to formulate, in order to formulate the second order ordinary differential equation, we have to differentiate. We have differentiated twice. In order to formulate the second order ordinary differential equation, we have differentiated it twice. To eliminate. Why should we differentiate twice? To eliminate both arbitrary constants. So that's a point. Both arbitrary constants. So ladies and gentlemen, right now, after giving you that little introduction, I would like to present to you example 8. Example 8. So let us solve example 8. So example 8, actually it is a simple question. State that formulate the differential equation. Formulate the differential equation. Formulate the differential equation whose solution is y is equal to ax plus b. Y is equal to axa plus b. Wonderful. Solutions. Solution, we have to follow just 2 to 3 steps and then we are done. The first step, excuse me, the first step, check the number of arbitrary constants. How many arbitrary constants are there? So there are 2 arbitrary constants. 2 arbitrary constants. And those arbitrary constants are A and B. Okay? So it means that in our given function y is equal to ax plus b, this is equation 1. So here we say second step. So the second step we say that differentiate equation 1. Differentiate equation 1. So differentiate equation 1, we apply d dx to both sides of the equation 1. So, and then for the equations on the right hand side, we have 2 terms, d dx of arbitrary constant a plus what d dx of b. So if we differentiate with this one, we say that we have dy dx. Then differentiate this one, we say that a, we take a out, we have dx dx, which is equal to 1. But b, it is constant. Whenever we differentiate any constant, we get 0. Alright? So dx over x is equal to 1. So ladies and gentlemen, you have to enjoy the beauty of basic engineering mathematics, the beauty of scientific mathematics for the rest of your life. Okay, so there we have y x is equal to b is equal to a, is equal to a itself, because the x over x is 1. So we go for the third step, ladies and gentlemen, of the study here. We have, so this we formulate equation 2. So differentiate, find the second derivative, differentiate equation 2, differentiate equation 2 above. Differentiate equation 2 above. So differentiate the equation 2 above, dy dx is equal to a, we have to apply derivative with respect to x on both sides. So dy dx, this is equal to d dx of arbitrary constant a. So dy dx with respect to x, this gives us d dx is equal to what? Is equal to 0. right? Because 8 is constant. So once when we told you in differentiation that when you are differentiating a constant, the answer is 0, right? So the answer is 0. So this is the solution. This is the differential equation. So you say that therefore the differential equation is second derivative of y is equal to 0. Okay. Okay, so ladies and gentlemen, in case you have any question, don't hesitate to ask in the comment section. So right now, let me present to you example 9, and I will teach you how you can formulate second order differential equation. So we say this question states that formulate the differential equation formulate the differential equation formulate the differential equation corresponding. This is, you have to refer differential equation tutorial sheet. Differential equation tutorial sheet corresponding to y squared is equal to a b squared minus x squared. When A and B are arbitrary constants. So you've been asked to formulate the differential equation corresponding to that given functional solution, which is y squared is equal to a, then open bracket, b squared minus x squared, when a and b are arbitrary constants. Right? So solution. So solution, you say y squared is equal to a and b squared minus x squared. Okay? So remember that the first step, assume that you are not given too much descriptions, that the first step, check the number of what? Check the number of arbitrary constants. So there are how many are there? 2 arbitrary constants, which is a and b. So because these two arbitrary constant, in order to eliminate the two constants, we have to differentiate the given function twice. This is question 1. So before we differentiate, we have to expand. Expand the function in question 1 above. So we say that here we have y squared is equal to a b squared minus x squared. So when we expand, we say that this is y squared is equal to ab squared ax squared. Right? So this will make question 2. Then we go for the third step. The number of steps sometimes depends the given function. Second step, the third step, we say that we have differentiate. We have differentiated in question 2. Okay, so differentiate this equation 2. We have y squared is equal to ab squared minus ax squared. So differentiate, we have to differentiate both sides. d dx of y squared is equal to d dx of what? Of ab squared. This is the product of the what? Of the arbitrary constant. d dx of ax squared. Right? So if that's the case, we have to understand when differentiating y, we are going to have y or twice by using the power rule. So you have twice, then you have single y, means y 2 minus 1, and then you have what? Changing y, changing x. Then this is equal to what? This is the product of arbitrary constant. So if you differentiate the constant, you get 0. Minus what? This the 8 is constant, so we have d dx of what? Of x squared. So this is equal to what? This is equal to 2y dy dx is equal to what? Is equal to negative a dx. Means if you differentiate it by using the power rules also, this will give us expression like that. So this will be 2y dy dx. This is equal to negative twice ax. Okay? Negative twice ax. So, if that's the case, okay? If that's the case, we have that expression. So suppose that this is equation 3. Question 3. So we have eliminated one arbitrary constant, which is b squared. We still have arbitrary constant a. So we have to eliminate it. How are you going to eliminate? You have to differentiate the given function twice. Or the functions this which showed us equation 3 twice. So that will be the first step. So the first step, we say to differentiate. Differentiate equation 3. So differentiate equation 3. Here we have two functions. Products of the two functions. We use the product rule to differentiate this. Okay? With this one we use just power rule. So product rules, so we say that you have to recall for the product rule, we say that d dx of what? of P times Q. This is equal to what? You keep P constant, you differentiate Q, and then you keep plus what? You keep Q constant, you differentiate P with respect to X as a product rule. So for this equation 1, we say that let P is equal to 2y and let Q is equal to dy dx. Just to remind you. Then we say that we have to find differentiate P with respect to x. If you differentiate P with respect to x, this will be twice dy dx. Then we have differentiate Q. So differentiate Q, we are going to get the second derivative of y with respect to x. So we say that instead of P and Q, we say that d dx of what? Of twice y dy dx is in product rule. Q, it is twice y twice y. P it is twice y. dq dx. dq dx is second derivative. So second derivative of y with respect to x. Then plus q. Q it is dy dx. Right? And then times sorting dp dx. dp dx. What is dp dx? dp dx, it is twice dy dx. Right? So this is a little bit concept, so you can just write concept. Okay, next we say that this is equal to twice y second derivatives of y with respect to x. Then this will make what? Twice, then dy dx squared. So simply the derivatives of equation 3 with respect to x, it is what? Twice y dy dx. Right? So this one is equal to what? Is equal to twice y second derivatives of y with respect to x plus what? Plus twice, then dy dx. The first derivative we stick to 2. We stick this power or raised by 2. Then that is, so let now substitute it. Let now substitute. Let now substitute it, yes. So suppose that this is equation 4. Okay, question 4. So you go for the fifth step. Substitute equation 4 in equation 3. So to substitute, it means on the right hand side we have 2y twice y, then second derivative of y with respect to x plus twice, then we have dy dx square. This is equal to negative 2a. That is 2a d dx. If you differentiate with x respective to what? To 1. So on the left hand side we have dy dx plus twice dy dx squared. It's equal to negative 2 a, dx it is 1. 2 is common, so you can take it out. Once you take it out, okay, you can also divide by what? Means you can divide by -2 by -2. So simply say that these two will cancel. So you have -y dy dx. Then minus what? dy dx raised by 2 is equal to a. So this is equation 5. So because we are looking for the differential equation, then we have to take our solution and substitute it in equation 3 to eliminate the constant. So we got the value of arbitrary constant. This is the value of arbitrary constant. So in here, in this equation 3, we have also the first derivative or the first order differential equation, but we have a also. So we cannot substitute, remember that, you cannot substitute equation 5 in equation 1 because you have to arbitrary constant while you have only the value of the one of the arbitrary constant, which is a. So what will be the next step? This is all about example 9. Remember that I told you my examples always arranged sequentially. God helps me to arrange the examples that I'm teaching students sequentially. So the sixth step, we say that substitute equation 5 in equation what? In equation 3. Okay? So equation 3 states that twice y dy dx is equal to -2ax. So to substitute the value of equation 5, the value of a here. So ladies and gentlemen, we're gonna have 2y dy dx is equal to -2. Then we open bracket, we have what? Minus y, second derivative of y with respect to x. And then we say that minus this derivative which is dy dx, and this is a square. Okay, so if this is the case, here we are going to have the square bracket. Okay, the square bracket. Okay, the square bracket. So if this is equal to 2y dy dx, okay, so if you multiply, this gives us what? Twice y, second derivative with respect to x, and then plus twice dy dx. Right? So we can divide by 2 and divide the entire question by 2. So once we divide, we get y dy dx is equal to what? Is equal to y dy dx plus what? Twice dy dx squared. So that's the solution of the given differential equation. You can collect the terms . Oh, excuse me, I forgot here x. Thank you, God. I forgot here x. So x, so here we have twice yx, and also here we have times x. And here we don't have 2, excuse me. We have x, and here we have xy. Yeah. So you have just to simplify like this. So you have y dy dx minus xy dy dx squared minus x dy dx squared is equal to 0. Or in other way, you can say that this is xy. Second, you can bring this on right hand side, second derivative of y is respective to x. Okay, then plus what? Plus x. First derivative with respect to x square. Then this minus what? Y dy dx. This is equal to 0. So either this form of the equation is the solution of the given differential equation. According to my research as a teacher, in order to help my students, especially those who are supporting my research, I found that in test 2, these questions of formulating either first or second order, but second order is a common order differential equations is a common question in test 2 and also in the final exam. But depends to how it has been set. So you say that the differential equation corresponds to the given function of the solution. So the differential equation is second derivative with respect to y, and then plus what? X this one minus y dx. This is equal to 0. Okay? So this is the solution. That's the solution. Okay, good. Let us go to example 10. So example 10, this is a function of complementary solutions of auxiliary quadratic equations of differential equation. With what? Yeah, with equal roots. Form a differential equation. Form a differential equation whose solution is y is equal to a minus 2x ax plus b. Form a differential equation whose solution is that one. Solution. The first step first step, we say that check number of arbitrary constant. Arbitrary constant. So there are two arbitrary constants, A and B. Okay, A and what? And B. And then if this is the solutions, so we have to think how we can eliminate the arbitrary constant A and B. So the second step, before we differentiate, we have to think how can we, because the challenge in this is concept, right? This is concept right now. The challenge is e power 2x is differentiable infinitely. If you differentiate e power 2x, you get 2e power 2x. If you differentiate it again, you get 4e power 2x. If you differentiate it again, you get 8e power 2x. So you differentiate it infinitely. So with this, with all of the form of this form of differential equation, you have to simplify first. You have to eliminate the exponential function. Okay? So you have to have arbitrary constant, you have to eliminate the exponential function. So we say that eliminate. So this is, okay, eliminate e power 2x from what? From right hand side of what? Of equation 1. How do we do it? So it means that when we have equation 1 with e equal 2x, 8x plus b. Pause the video and challenge yourself how you can eliminate the exponential function, the natural exponential function e power 2x. So you have to multiply by e power. You have to multiply. So multiply equation 1 above with what? With e power negative twice x, because the base of exponential function will be the same, and the exponents is not the same, but we can do the simplification. We can add the exponent if the base is the same. So we have e power negative 2x times y is equal to what? Is equal to e power 2x times e power negative 2x times a x plus b. So e power 2xy, this is equal to what? E power twice x minus twice x, which is just like addition. Then we have arbitrary constant ax plus b. So we have e power 2x y, means it's just like we divide by e power 2x both sides. Here we're going to have e power 0 ax plus b. This is equal to ax plus b. So this is equation 2. So now we have eliminated the natural exponential function a, which is differentiated several times without limitation. So next we say that the third step, ladies and gentlemen, differentiate. So now we can differentiate equation 2 above. Differentiate equation 2 above. So differentiate equation 2 above here. We have e power negative twice x y. Then here we have axe plus b. So in order to differentiate, you have d dx of e power negative 2xy. This is equal to d dx of ax plus b plus what? D dx of arbitrary constant b. So this is the product of the two functions. You have to use product rule. Simply we taught you the techniques of product rule. You just give this is p, this is q, or this is u, this is v. So let us keep e power negative 2 constant. Differentiate y, we get dy dx, then plus. Then let us keep y constant. Let us differentiate e power negative 2x. The answer is negative 2 e power negative 2x. Then let us differentiate a as beta constant x. The answer is a. Let us differentiate b. The answer is 0. Right? I believe that you're enjoying the beauty of basic engineering mathematics, and basic scientific mathematics. I'd like to ask you once again, to, in case you feel from your heart that you want to offer our God freewilling offering for what He brought in your hands, without even paying a piece of coin, you can offer our God your freewilling thanksgiving through this telephone number in order to support the running cost for this program. And your offering will be received with respect, with too much respect and fear of the Lord. So you have e power negative 2x dy dx. Then we have what? Negative 2 y e power negative twice x. Then this is equal to what? This is equal to arbitrary constant 1. So, wow, wonderful enough. We have managed to substitute, we have managed to eliminate one of the arbitrary constant, which is b. So now we have a. Right? So to have a, again, we have to make sure that we differentiate. We differentiate the entire function. So we differentiate for the second time. So first state, we have differentiate because if we differentiate on this right hand side would be 0. First state, we differentiate. This differentiating the derivative. The first derivative is called the second derivative. Differentiate equation 3. So differentiate, this is the products of the two functions, and this is the products of the two functions. So we are going to use product rule to differentiate this product of the two functions, and you have to use the product rules to differentiate these products of the two functions. So let us begin here. Product rules is very simple. I taught you differentiation. So for this case, you say that we have e power negative 2x. Then we say d dx of dy dx. Then we say that this is plus what? We keep constant dy dx. We differentiate e power negative 2x. We get negative 2 e power negative x power negative 2x. Then if you differentiate what? Differentiate the arbitrary constant a. Okay? So if that's the case, you say that e power negative 2x, then we have second derivative. Then this is minus twice. Then e power negative twice x. Then we have dy dx is equal to what? To 0. Excuse me. I just did one part. Just that is one thing. So I forgot to differentiate this function in product. So let's keep constants 2y. So it will be negative 2y. If you differentiate this one, we'll get negative 2e or negative 2x. Then again we say plus. Now we are going to have 2 because this is common. Then we keep e power negative twice x, differentiate y. So dy dx. This is equal to d dx of n. Okay? So if that's the case, you say that here you have e power negative twice x dy dx. Then this will make k minus twice e power negative 2x, then dy dx. And then she say that this will make plus what? Plus 4y e power negative twice x. Then we say that this make the next term, which is 2 e power negative twice x dy dx if differential constant we get 0. So this is equation 4. So equation 4 will say that this is common. So we go for the next step. We say that the first step, simplify question 3, question 4 above. So to simplify, e or negative trace x is common. So because it's common, we can eliminate dt, or we can simplify t, divide it on the both sides. So this is minus twice, then first derivative coefficient, and there we have plus what? 4y, then plus what? So it will be plus what twice. First order differential coefficient. This is equal to 0. Let me cross check. We have like terms here. Do you have like terms? Yeah, we do have. So let us cross check these like terms, if they do cancel or they do add each other. That's 4. That's 2. So even this one is minus because of this. So if it is minus, then this one also it is minus. We divide by e power negative 2x, e power negative 2x. Okay, so let us continue on formulating the second order differential equation. So we divide by both sides. So on the right hand side we have the second derivative y is respective to x. Then this term and these terms are the same, so you add them. So you have negative 4, first derivative is degree of with power of 1, and then plus 4y is equal to 0. Or vice versa is true. So therefore, the solution of given, not solution, should be the differential equation is second derivative minus 4 divided by x minus 4y is equal to 0. So that's the solution for the given differential equation, okay? So that's you have to do the same process for the entire examples. So let me give you example. It was example 8, 9, 10. Okay, so it means that let me present example 11. And this is homework 4. Form the differential equation of the given solution. Solution is so form differential equation of the given solution of the given function. Okay, so I'm trying to look the relating example. So this is, you have to refer to the sheet, the 18. So first the function divide the x. No, y y is equal to e power x a cos of what? A cos of x plus b, no? Y is equal to trace x or trace x minus x squared minus 1 y is equal to 2x squared minus 1. Then I find plus what? Arbitrary constant c. Then we have what? E power negative x squared. E power negative x squared. Then b okay, so B we say that okay, so B it is y is equal to E or negative bx. Then here we have A x plus B. So make sure that you do the homework. In case you have any questions, please don't hesitate yourself to ask in the comment section. So I ask you that please you have to keep on enjoying the beauty of basic engineering and scientific mathematics. And also keep on reviewing and watch this video several times as well as you can. This is the end of session or lecture 4 of ordinary differential questions. I invite you to join me in the next lecture 5 of ordinary differential questions, where I'll take you from one step to another step and we'll be enjoying the beauty of basic engineering and scientific mathematics. This is Olenjolai from the United Republic of Tanzania. Don't forget to subscribe, please. Do it right now. Don't forget to send your free willing thanksgivings in case that you hear the instructions, and you have to offer it by faith and also by authority, by free willing heart. And also, I would like just to welcome you, keep on enjoying the contest for the connects and content. So the contest for the differential question. So this is the end of lecture session 4 or lecture 4. May God bless you abundantly. And I thank God who have given me opportunity to be part of your education. I thank God who have given you opportunity to watch this program. May God bless you abundantly. Keep on sharing this information to other students across the entire country of Tanzania and even source foreigners, because you know that basic engineering and scientific mathematics is universal. So may God bless you, and I ask you that to pray for me and keep enjoying, but make sure that you do the homework and submit the homework in the comment section. So may God bless you until we meet, and keep it in touch.